As you're working your way through this video, I encourage you to have both the graphing calculator open and ready to go, as well as the note sheet that accompanies, it says Exponential Derivatives Discovery Using the Graphing Calculator title at the top. And you can see for the purpose of this exercise is for us to kind of see some relationships between an exponential function and its derivative. And ultimately, the goal is to figure out a formula for the derivative of an exponential function. We see there f of x equal to a to the x. A is some value. What is the derivative of a to the x? So in order to discover what's going on, you see with the first bullet point, we're going to begin with the particular case of 2 to the x. What's the derivative of f of x equals 2 to the x? That's a classic exponential function, and we want to find its derivative. So let's get the function and its derivative on the screen. The way we're going to do that, you see on the graphing calculator there, we have to make a equal to 2. On the calculator, we're going to type in the number 2, and then we're going to store it, which is over here on the left, into the a value. Now we see a here in green, so we're going to do alpha and then hit the math button, and a appears on the screen. As soon as we hit enter, it has now stored 2 in for the value of a. In other words, if I were to write 7a right now, a is 2, so this calculator's thinking is 7 times 2. This should produce an answer of 14 when I hit enter. And lo and behold, it does, because a is now equal to 2. Additionally, for the first bullet point, we see at the very end that we also want to put in that decimal, 1/10,000. That's 3 zeros and then a 1 in for h. So we're going to type in the number and we're going to store it. Now h is located over here at the exponent key, so we're going to do alpha exponent, and we see h appear on the screen. So now we've got h being stored as that very small number. And the reason why, as you see there for y2, is that we're looking to put the derivative in. Remember, the derivative is the limit of the difference quotient, the limit as h approaches 0. We can't make h equal to 0. We can make h very close to 0 in order to get what our desired effect. So now we're going to go to the y equals, our equation editor. So up here, hit y equals, and we're going to put a to the x and y1. All right, so I'm going to do alpha a, and I'm going to raise it to the x power. And I'm going to hit enter. So now 2 to the x is being graphed. So if I just do a quick, just so you see here, zoom, let's do zoom 6, because it doesn't really matter at this point. This is the graph of 2 to the x. Okay, we're going to change the window in a second. But let's go back to y equals. And I also want to put in the derivative of 2 to the x. Now you can see there, that means I'm going to make y2 equal to that expression. So I need a fraction. So that's my alpha y equals. And option number 1 is a fraction, so I'm going to hit enter. And in the fraction, I'm going to have as the numerator a to the x plus h. All right, so alpha a, and I'm going to raise it up to the x plus h power. In other words, I'm creating my limit of the difference quotient. I'm creating my derivative. Right, we get out of the exponent, minus a to the x, so minus, and I'm going to do alpha a up to the x power. Okay, and then I'm going to go down to the denominator. I just want h, so alpha h. So this expression right here, after I hit enter, this is the derivative of a to the x. This is the derivative of 2 to the x when h is approaching 0. And remember, I made h very small, so we're going to get the derivative of 2 to the x on our screen in a moment. Well, let's go to the second bullet point on the paper. We see we want to look at a specific viewing window. So I'm going to hit the window button, which is right up here. And I'm going to make my x-min equal to negative 4.7 and my x-max equal to 4.7. And my x scale, which is how often we put a tick mark, we'll just leave that as 1. And then the y-min is going to be negative 2, and the y-max is going to be 32. And we're going to put a tick mark every 5 units. And now when I take a look at the graph, so I'm going to hit the graph button right up here. And here's the graph of 2 to the x. And here comes the graph of the derivative of 2 to the x. The third bullet point says to write a statement or two comparing the similarities and differences of these shapes. Well, what do you notice? On first glance, what do you notice about the blue curve, which is 2 to the x, and the red curve, which is the derivative of 2 to the x? Yeah, they're pretty close. They've got the same shape. They're both curved upwards. They're both increasing rather quickly. So it seems like they're quite similar to each other. Okay, and that's a good statement to write down for number 3. Bullet point number 4 says, well, what if we look at these two functions in a little different manner? What if we were to look at them as a table of values? All right, so we're going to go to the table command. When we see up here, the table setup is up here in blue. So we're going to go second window, and we're going to make our table start equal to 0, which mine already is, and the delta table equal to 1. And now we're going to actually look at the table. So I'm going to do second, and then I'm going to hit the graph button, because notice that right up here it says table in blue. So second, graph, and here's the table. So here's my x values, 0, 1, 2, 3, 4, 5, 6, 7, 8. Here's the y values of 2 to the x when we plug in 0 through 8. So 2 to the 0 is 1, 2 to the first is 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, so on and so forth. Okay. This is the value of the derivative for each of the same x values. Okay, and with the exception of this fraction right here, don't worry about that one at this point. Well, bullet point number 5 says, write a statement comparing the growth patterns of the blue column and the red column. What do you notice about how the blue column is growing? Yeah, if you're probably looking at that and say, hey, it's doubling every single time. 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, it doubles and doubles and doubles. Okay, so the blue column is doubling. Is the red column doubling? Well, it's kind of hard to tell at first, but when we see this, 11, 22, 44, 88, yeah, in fact, the red column is doubling as well. So a nice answer for number 5 there is that both columns are doubling. Now, it makes sense that the blue column should double because the function, again, is, actually, we can go right up here, it is a to the x. All right, it's 2 to the x. That means every single time we multiply by 2. So it should double. But if the derivative is doubling as well, that means that there's some kind of 2 to the x in our derivative as well. But we always have these messy decimals as well. So let's see if we can figure out what's going on with this decimal. And to do that, we're going to go back to y equals, and we're going to create y3. And y3 is going to be the ratio of 2 to the x and its derivative. So we're going to make y3 equal to the y2 function divided by the y1 function. To get the y's to appear on the screen, we have to go to alpha, and then we're going to hit the trace button. When we do so, all right, we see y2, so we'll hit enter. And we're going to divide y2. We're going to divide the derivative of 2 to the x with 2 to the x. So I'm going to go alpha trace again, and this time I'll pick y1. And I'll hit enter. I'm going to go back to my table, so second table. And here is what happens when we divide the red column by the blue column. Now, it makes sense, right? 0.6932 divided by 1 is itself. 1.3863 divided by 2 happens to be the exact same number. We get the exact same number in y3.